All right, so good evening again. So today we'll be looking at transformation of graphs. And in the table below, I sort of like summarize the different transformations that we would have to learn. All right, for example, the first row or the second row of the table talks about the graph of h of x is equal to g of x plus a. So the graph of h of x is equal to g of x plus a is a vertical translation of g of x by a unit. So in other words, if I can get the graph of g of x plus a from the graph of g of x by moving the graph of g of x either vertically upwards or vertically downwards. So h of x is equal to g of x plus a is a vertical translation of the graph of what? G of x by a unit. So here's something that is important. What happens to the point PQ? So in a vertical translation, what this is saying, the column that talks about PQ becomes, what that column is looking at is what happens to, let us say, the point PQ in a vertical translation. So the point PQ in a vertical translation is going to become the point P, comma, Q plus A. So in other words, the x coordinate remains the same and the y coordinate either increases or decreases by A. So the point PQ in a vertical translation becomes the point PQ plus A. So if A is greater than 0, essentially that means if A is positive, if A is greater than 0, which means that A is positive, the movement is vertically upwards. If A is less than 0, meaning that A is negative, the movement is vertically downwards. So h of x is equal to g of x plus a is a vertical translation of g of x by a units. Let's have a look at the second one. The second one says h of x is equal to g of x plus a. H of x is equal to g of x plus a. Now, this is a horizontal translation of g of x. So in other words, we can get the graph of h of x is equal to g of x plus a by horizontally translating the graph of g of x. Now, horizontal translation means that you're either going to move it to the left or you're going to move it to the right. Now, what happens to the point PQ in a horizontal translation? In a horizontal translation, the point PQ in a horizontal translation is going to become the point P plus A, comma, Q. In other words, the x-coordinate either increases or decreases by A, and the y-coordinate remains the same. So in a horizontal translation, the y-coordinate remains the same, but the x-coordinate either increases or decreases by A. All right. Now, the third translation is h of x is equal to g of ax. H of x is equal to g of ax. Now, this is a horizontal stretch of g of x, parallel to the x-axis by a factor 1 over a. So now in this type of translation, the point PQ is going to become the point 1 over a PQ. In other words, the y coordinate remain the same, but the x coordinate either increases or decreases by a factor of 1 over a. A lot of this will be made, let us say, 100% clearer when you actually do an example. H of x, the fourth transformation is h of x is equal to a g of x. Now, this is a vertical stretch of g of x parallel to the y-axis by a factor a. So in this type of transformation, the point PQ becomes the point PAQ. The x coordinate remains the same, but the y coordinate increases or decreases by a factor a. What else about it? So remember, if you remember from CSEC, in a transformation, the point before the transformation is called the object, and the point after the transformation is called the image. So in all of our examples that we're looking at and we're talking about, PQ is a point on the object. And what it becomes, 1 over a P Q, P, comma, AQ, what it becomes is a point on the image. Now, h of x is equal to minus g of x. This is a reflection of g of x in the x-axis. So when you reflect a point, let us say, if I reflect the point PQ in the x-axis, it becomes the point P minus Q. In other words, the x coordinate remains the same and the sign of the y coordinate change. And the final transformation that we have to learn about for our syllabus is h of x is equal to g of minus x. This is a reflection of g of x in the line in the y-axis. It's a reflection of g of x in the y-axis. Now, when you reflect the point PQ in the y-axis, it becomes the point minus PQ. If you reflect the point PQ in the y-axis, it becomes the point minus PQ. All right, example 38. Example 38 is asking us to transform the graph of f of x is equal to x squared to graph the function g of x is equal to x squared plus 2. So here's what we can do. Let us get some points on f of x. Let us get some points on f of x is equal to x squared, and the corresponding point on g of x is equal to x squared plus 2. Let's start with when x is equal to, let us say when x is, all right, getting back to it. So we have x and we have f of x is equal to x squared. So let us say when we say when x is equal to, let us say, I don't think we can use minus 9. Let us say when x is equal to minus 2. When x is equal to minus 2, f of x would be equal to minus 2 squared, which is 4. So this is the point minus 2, 4 on f of x. Now on g of x, it would be minus 2, 4 plus 2, which is 6. So in a vertical translation, you're either the x coordinate is going to remain the same, but the sign, sorry, in a vertical translation, the x coordinate remains the same, but the y coordinate is either going to increase or what, or decrease. And in this case, it's going to increase by 2. So let us see what happens when x is minus 1. F of x would be equal to minus 1 square up here as well, which is positive 1. So this would be the point minus 1, 1. And the point minus 1, 1 is going to become the point minus 1, 3. The x coordinate remains the same, and the y coordinate increases by 2. When x is 0, we get f of x would be equal to 0 square, which is still 0. So this would be the point 0, 0 on f of x is equal to x squared, and on g of x it would become the point 0, 2. All right, similarly, we're going to have the point 1, 1, which is going to become the point 1, 3, and the point 2, 4, which is going to become the point 2, 6. All right. So if we wanted to, we could draw the graph of f of x, but let's start by drawing the graph of g of x. We have minus 2, 6. That would be here. Minus 2, 6 is here. We have minus 1, 3, which would be here. We have 0, 2, which is here. We have 1, 3, and we have what? 2, 6. This is the graph of g of x. G of x is equal to x squared plus 2. All right. Now g of x is equal to x squared. Sorry, f of x is equal to x squared. You'd have what? Minus 2, 4. That would be here. You have what? Minus 1, 1, which is here. You have 0, 0 here, 1, 1, and 2, 4. So this is the blue graph. Right, not so perfect. All right, let me try and get this a little bit better. All right, this is f of x is equal to x squared. So the graph of what? We were asked in the question to transform the graph of f of x is equal to x squared to graph the function g of x is equal to x squared plus 2. And what did we do? We obtain points on the graph of f of x is equal to x squared, and then we obtain points on the graph of what g of x is equal to x squared plus 2. Now, g of x is equal to x squared plus 2 is a vertical translation of f of x is equal to x squared vertically upwards by 2 units. And so to get the corresponding points on g of x is equal to x squared plus 2, the x coordinate remains the same, and the value of the y coordinate increases by 2. All right, example 39 asks us to sketch the graph of y is equal to 1 over x, and hence sketch the graph of y is equal to 1 over x minus 2. So the first thing we need to remind ourselves of is what does the graph of y is equal to 1 over x look like? So I'm sort of just doing a little sketch of it to the left. So if this is our x-axis and this is the y-axis, the graph of y is equal to 1 over x looks something like this. So this is y is equal to 1 over x, where both the x-axis and the y-axis are asymptotes. The y-axis is a vertical asymptote, and the x-axis is a horizontal asymptote. Now, the horizontal, an asymptote is a straight line that a graph approaches, but it doesn't touch. So let's get some values. We have values of x. We have also y is equal to 1 over x. So, for example, if x is equal to, let us say, minus 4, let's use minus 3. If x is minus 3, we'll just extrapolate. Y would be equal to minus 1/3. So this would be the point minus 3 minus 1/3. If x is minus 2, we're going to have the point minus 2 minus 1/2. If x is minus 1, we're going to have the point minus 1 minus 1 over minus 1, which is minus 1. If x is, let us say, 1/2, minus 1/2, if x is minus 1/2, y would be 1 over minus 1/2, which is really the same as saying minus 2. So the point is going to be minus 1/2, 2. So if we plot those points, we have something maybe like here, minus 3 1/3. Let's say that's somewhere around here. Minus 2 1/2, which is probably here. 1 minus 1 minus 1, which is there. And 1/2, 2, which would be about here. So if we sort of try and draw this graph, we might get something looking like this. So this is the left side of the graph. Let's try this side first. Something might look like this. And the other side, this might look like this. All right, so we've just drawn the left side of the graph. The right side of the graph, it's something similar. You're going to get 1 1, 2 1/2, 3 1/3, 1/2, 2, something like that. So we might get something looking like this. We're doing so good a while ago. All right. So this is the graph of y is equal to 1 over x. Now, so this is now the graph of y is equal to 1 over x. Now, if we want to draw the graph now from this, sketch the graph of y is equal to 1 over x minus 2, we're going to vertically translate this graph 2 units vertically downwards. So here's the first thing. The x-axis was the horizontal asymptote. The x-axis was the horizontal asymptote. If you push this graph 2 units vertically downwards, the horizontal asymptote is going to become the line y is equal to minus 2. So this is y is equal to minus 2. For the original graph, the x-axis was the horizontal asymptote. But if this graph is moved vertically 2 units vertically downwards, the new horizontal asymptote is going to become the line y is equal to minus 2. From this, I can probably write my corresponding points. The point 1, 1 is going to become the point 1 minus 1. This point is going to move here. This point move here. And this is for a half. It's going to go 2 units down, so it's going to go to here. All right, and from this now, I can draw this half of the graph. All right, let's draw the other half of the graph. This point is going to move here. The point minus 1, 1 is going to move to minus 1, minus 3. The point a half, 2 is going to move to a half, 4. A half, 2 is going to move to a half, 4. All right, and this point is going to move to here. This point move to about here. And we have enough now to draw our graph. And the red graph would be the graph of y is equal to 1 over x minus 2, whereas the blue graph would be y is equal to 1 over x. All right, so example 40 says the graph of f of x is shown below. We're asked to sketch the graph of f of x minus 2, showing each point on the new graph. All right, so I guess we could identify some points, some easily identifiable ones, like here and here. These points are easily identifiable. All right, so we can look and see what those points become. We can look and see what those points become when we transform the graph. All right, now, ladies, gentlemen, the graph of f of x minus 2 is a horizontal translation of the graph of f of x. Now, if it's x minus 2, you're going to move the graph 2 units to the right. If it's x minus 2, you're going to move the graph 2 units to the right. All right, be very careful about the 2 units. And so let's move this graph 2 units to the right. All right, so the point, if we're going to move this graph 2 units to the right, the point 0, 2 is going to move to 2, it's going to move 2 units. Please note, it's actually 2 jumps for 1 unit. That's 1 unit. So if I move it 2 units to the right, it means I have to make 4 jumps. All right, so 1, 2, 3, 4. 0, 2 moves to 2, 2. 1, 1 moves to 3, 1. And minus 1 1 moves to 1, 1. So the final point is going to become that point. All right, now if you can easily move some other points, I guess it's not a bad idea. Maybe this point here, 2 units, 1, 2 would come here. Not so hard to move. This point here, 1, 2 units would come here. Not so difficult to move. Just to make it easier for us to sketch. We could probably move this point as well, and this point. So the first point would move 1 unit, 2 units to here. The second point to here. So we have enough points. We can now sketch the image. All right, that's one side. This is the next side. And this is the graph of f of x minus 2. So if it's minus 2, you move it to the right. If it was positive 2, you would move it to the left. And this is the graph of f of x. So this is y is equal to f of x, and this is y is equal to f of x minus 2.